Hi, welcome everyone to this video. In this video, I am going to go over panel quantile regression, a panel quantile ARDL regression model in R by discussing a problem that was identified by one of the viewer of my previous video in which I estimated panel ARDL model. So the code is basically the same. First of all, I will highlight that issue that R does not solve it automatically. It assumes the data as a time series, and for the case of panel data, that problem is not sorted automatically, just like in other softwares like Stata and eViews. So in this video, first of all, I will start with the problem and then I will tell you the solution. Hopefully in your future panel data, dynamic panel data estimation models, you will use this solution to solve that problem. Otherwise, it will be creating a problem in your data which may lead to wrong results. So first of all, I will start with, first of all, I will clear my existing data sets. I will install my QReg PD RQPD library, which is the panel data quantile regression model. And I will load the relevant libraries, and there is a seed command which fixes the starting point of simulations which are done within the quantile regression. If you don't fix it, then every time when you done use the quantile regression, it will change the simulation random number generator, and it may give you different results. So we fix it so that it can be replicated. So now I will read the data using this command, and the data is loaded. The libraries that I require is readr to read the CSV file, rqpd for panel quantile regression, tidyverse for data management, PLM for panel data models, and panel data declaration. HMSEs, it include miscellaneous data files with data packages which may require to calculate a lag of a variable. This ls is command that can be used to list the variables that are in the data file. Then because we need to use the quantile regression, I will use this Shapiro will test to check that if the data is not normal, and for my case the dependent variable is not normal. So this way you can justify. And now if you see the data file, if I click it here, you can see the data is sorted into for year, not for a country. So if you are using a panel data, ideally it should be sorted for country and then for year. So for that, this command can be used. If you run this and go back to the data file, you will see that it is sorted for year and then a country, then for a year. Then you can in my data file, my one of my variable is in scientific notation, which might create problems later on when you are trying to make a graph or interpret it. So what I do is I change it to not scientific notation using this command. When I run it, if you see that it will be standard numbers. Okay, so this will help in many cases. Now the problem that was missed in my previous video, which one of our reader and one of the viewer pointed out. So if you run a lag of a variable, which is df dollar $l dot gdp equal to lag with capital L dollar df dollar gdp comma -1, means it is actually +1, means first lag, -1 means first lead future value. So I will calculate the lag. So when I run this command, ideally the first value should not be calculated because there is no lag available. But in panel data, for each new country, the first value should be empty because it does not have a previous value. So it is not emptying the first value of each data, just like here. For Algeria, first value it should be empty. So this is the problem which exists throughout the data. So if you ignore it, then it will have one wrong observation for each cross section, and it will lead to wrong outcome. So this was a problem that was there in the previous video that I estimated, in which I used these lags and these differences and calculated the panel quantile regression. But in this video, I will tell you how to solve that problem. First of all, you arrange the data according to country, which is already done. Then you can do is declare the data as a panel data. So df.pd is equal to panel data.frame df, and indexing it with cross section identifier and time identifier. When I do this, it will it will declare data as panel data, and eView Stata, the software will know that each cross section has a name, each entry has a name, so it has mentioned it. But in the previous file, it was just assuming it as a cross sectional or time series data. Okay, so first of all do this, then you can have a look that if any of the variables is numeric or not. So for that use str.pd. When I do this, if I see the data, all of my variables should be numeric. Okay, so I will start with here. So country, it should be crosshead. So year variable should be numeric. It is now, it is a factor, it can be converted into numeric. FMD, innovation numeric, cluster numeric, so LME numeric, GDP, it is character. Okay, so it should be sorted. All other variables are numeric, and I calculated LGDP, which is also character. So first of all, I have to drop that LGDP. So what I will do, I will go back and load the data again, so that that variable is that LGDP which was wrongly calculated is removed. Then I come here, sort the data, and declare it as a panel data and convert it into scientific non-scientific notation. If I see its string again, if I go up, you will see that now GDP is again character. So I will convert that into numeric. For that I will come down, I will declare df.pd GDP as numeric. This above command is simple panel quantile regression, which was also shown in previous video, that RQPD GDP equal to two variables and fixed effect with country. Lambda 5 means its median, and then fixed effect method. So it will show you the results. Okay, and then what I will do is, in this video now I need to calculate the lag. So the command is data file equal to select a data file, group it according to country, arrange it according to year, then mutate and calculate that lag. If you calculate this, let's calculate all of them and convert the numeric, the lag value into numeric also. If you go into the data file, you will see that data, now I will have to arrange it according to country again. Now you will look that all of the lag variables have first value empty for each country. So this problem is sorted. Now your data is actually representing what it should represent. Similarly, we can calculate the first differences from the lag and then arrange it according to country. If you go back, because for panel quantile regression I need first differences, panel quantile ARDL, so all of them have empty first values. So this data is cleaner, has sorted the problem. So I will run the panel quantile ARDL. For that, the specification that I use is called ECM equation method to estimate panel quantile ARDL. The specification is that if you have an equation y is equal to a plus bx plus cz, then you can convert it into delta y equal to a plus b delta x plus c delta z. So these are coefficients and these are variables. I will separate it. These will become first difference equation. Then add now next variable b1, that will be lag of y, plus b2 lag of x, plus b3 lag of z. So this will become your ECM equation. This lag of y will show the coefficient of convergence. It should be negative. These coefficient will become long run, and you have to interpret it by dividing these b2. So I will give the formula: the long run effect of x on y will be b2 divided by b1. Similarly for z, b3 divided by b1. See, this way you can calculate the long run effects, and the b and c are short run effects. And beta 1 b1 is very important, it should be negative. for each quantile, because it will be calculating at 25 percentile, 50 percentile, and 75 percentile. So this is the method. So same way, d.gdp, d.gcf, d.labor, l.gdp, l.gcf, l.labor. So these are calculated here. So when I run this command, it may take some time in the background to calculate, and it is shown here. So the command has been done. So I need to get the summary. If I run this, it will show me the results. I will have to increase the size of the screen. It will take some time to convert the output into relevant format, because the cross sections are too many, so it will create that cross section dummies to make it a fixed effect model. So these are some outcomes. So if I come from the start, it is giving me the coefficients at 25 percentile. These are, so these two are long run. If I highlight them, these two are long run coefficients. They are significant. I just have to correct it by dividing with the LGDP coefficient. This is the conversion coefficient. It should be negative, but at 25 percentile it is not negative, so it is not converging. These are short-run coefficients, and this is median position. So the long-run coefficients are here. These ones. This is convergence coefficient, and it is negative. Convergence coefficient. This one, it is not negative. Also in median, and in also 75 percentile, the convergence coefficient is also positive. So this model is not converging at any of the given quantiles. So there is no long run relationship that exists, but you can run similar method. Similarly, you can run your model and you can calculate your panel quantile ARDL. The cross section specific effects are here, and they are assumed to have similar effect on overall model. That's why they are shown separately. So this is the way you can estimate your panel quantile ARDL using correct lags, and for the case of panel data, which the R does not sort it out automatically. You have to use the appropriate method to generate the correct variable. Thank you very much for watching. Do subscribe and like the video.